All right, so I think this is recording. Let's take a look at this problem. They want us to simplify 2 times the square root of 180 times n cubed. We know that with square roots that we can break apart multiplication. So we have 2 times the square root of 180 times the square root of n cubed. So let's come in and first let's work with this square root of 180 and see if we can't simplify it. So if I come over off to the side and do a little bit of scratch work, 180, well, since it ends in 0, it's definitely divisible by 10, and maybe we can just jump in and say 18 times 10. And you can play around with it and see if you can find the largest perfect square that divides 180. Start dividing it by the perfect squares. Start dividing it by 4, by 9, by 16, by 25, by 36. And 36 would work, I believe. That here I saw a 0 in 18 times 10. That's fine. So 18, I would jump and do 9 times 2, because 9 is a perfect square, and we have found a pair of 3's. Now, with the 10, I know it's 2 times 5, so we also have a pair of 2's here. So what this factor tree is helping us do is to recognize that if we want to take the square root of 180, that we can write 180 as 2 times 2 times 3 times 3 times 5. And we have found pairs. And we can split apart this square root. We can take the square root of this pair. We can take the square root of this pair. Now, the square root of 5, that's just a single value, and that's not going to simplify. We know, or at least I hope that you know, that the square root of 4 is 2, and that the square root of 9 is 3. And we cannot simplify the square root of 5. So this work over here, I tried to illustrate that the square root of 180 is the same thing as 6 times the square root of 5. So we can come over here and write 6 times the square root of 5 instead of writing the square root of 180. They look different, but they're the same thing. Now, let's tackle this square root of n to the third power is going to be a lot easier. If we have the square root of n to the third power, we know that exponent of 3 just means that you have repeated multiplication. And we also know that when you're taking a square root, that you're looking for pairs. So the square root of n cubed, we can break apart this radical and take the square root of this pair, n squared, times the square root of n. Well, whether we write it as n times n or n squared, this square root of n squared is n. And that's because we're assuming that these values, that these variables n are non-negative. So we can come in now and say, I can simplify the square root of n cubed, and that we can write it as n times the square root of n. So believe it or not, we are simplifying it. It looks right now like the original expression is more simple than our expression, but it's not, because we can, all of this is multiplication, and we can multiply in any order, and we can combine some things here in our multiplication. So we can look at the 2 times the 6, since that's not underneath a radical, and 2 times 6 is 12. And this n is not underneath a radical, so we have 12 times n. Now, this 5 is underneath this radical, and so is this n, and we can combine. If you have the square root of 5 times the square root of n, that is the same thing as the square root of 5n. So now they do consider this that we have simplified because we've applied these properties of this radical to rewrite this expression. I don't think there's any way that anybody would look at this and say, oh, that's obviously the same thing as this. You know, it's not so obvious. Our scratch work kind of proved that there's a lot of work to do in your head if you think that is obvious. All right, so I hope that helps. This is our final answer, the 12 times n times the square root of 5n. Talk to you later. Bye.